Inverse variation, so that's on 290. So if you think about what happened yesterday, think about Diego was his name, Diego in the newspapers. When the number of newspapers went up, what also went up? Right. So when one went up, the other went up. Okay? So inverse, let's take a look and see what happens there. Roberta Towns drives 150 miles on a trip. Her time in hours for the trip was determined by her average rate. In other words, how fast she was going. The following table shows the time t for the various rates r. Okay? So here's where it might vary inversely. The faster she goes, what's going to happen to her time? It's going to be less. The slower she goes, when her speed is lower, the time goes up. Okay? Which should make sense to you. An inverse variation is described by an equation in the form of xy equals k. What did k stand for again? The constant of the variation. Okay? So sometimes an inverse variation is written in the form y is equal to k over x. Okay? This also states that y varies inversely as x. Look at number 1. The area of a rectangle is 36 square inches. What are the possible integer values of its length and width? Okay. So if we think about that, the area is equal to 36 inches squared. Okay. The formula area equals L times W, length times width, for a rectangle. Okay. So if we say we know the area and length and width, okay, this is an inverse variation. The following table shows the possible values for length and width. And they put this all into a table. And it works well for this because 36 is a very familiar. So if my length is 1, what's my width? 36. Because 1 times 36 gives me the area of 36. How about 2? If my length goes up to 2, what happens to my width? Down to what? 18. If my length goes up to 3, 3 times what gives me 36? It goes down. 4. Goes up again. 9. And 6. Okay. It still went up. Your width still went down. Okay. Now here are some more in which you'll be seeing kind of like what you did yesterday. If y varies inversely as x, okay, and y is 6 when x is 18, find x when y is negative 3. So here we've got these formulas that they showed us before. We've got xy equals k, or we could use y equals k over x, okay? So depending on what I'm looking for will depend kind of on what formula I'm going to use, okay? So it says that x is 6 when y is what? This is example 2. Okay? This will equal k. 16 or 18 times 6 equals 108. That's our constant. Looks like we're going to have to use both of them anyway. Right, Amelia? Question? So if it says if y varies inversely as x and y equals 6 when x is 18, find x when, I know it's kind of worded weird. Then it says find x when y is equal to 3. So here's my formula. Let's use this and transfer the information over here. So if 108 is k, and I don't know x, and y is what? Negative 3. Okay? Here's what we're going to try to solve. Well, what's wrong with this so far? Dividing by x. So the opposite of dividing by x, let's try to clean this up a little bit. Multiply both sides by x. So a negative 3x is equal to 108. Divide both sides by negative 3. And 108 divided by negative 3 is a negative 36. Does it work our other way? Can we test it this way? So they said x was 6 when y was 18. Is that what they said? Right? No, y was 6 when x was 18. Y was 6 when x was 18. Find x when y is negative 3. That work? Divided by negative 2? Or times? Oh. Is that going to work? Not going to work. Not when it varies inversely. I don't think it's going to work. Let's stick with this. What? A hemisphere is 2. So you either have the eastern or western, or if you split it the other way, northern and southern, right? Okay, let's look at written number 1. Okay. If y is equal to 24 when x is equal to 8, find y when x is equal to 4. Let's throw these equations up here. Xy equals k. Y is equal to k over x. All right. So I can find k over here. I can find the constant because I have both x and y. So xy is going to be 8 times 24. And 24 times 8 is 192. Any questions there? All right. And then it says find y. It's going to work out great because all I got to do is plug in, what did we say k was? And they tell us x is, so 192 divided by 4 is going to give us the y that we're looking for. There are relationships that can be found, but I don't know if it makes it any easier to find them or to just do what's here. Like what happened to your, we knew the x, right? It went from 8 to 4. 8 to 4 is half as much, right? But remember, when one goes down, the other one goes up. So the relationship was still 2, except here we divided by 2, there we multiplied by 2. It's the opposite. That's how one got bigger when the other one got smaller. You try number 2. All right, number 2. If y is negative 6, when x is negative 2, it says find y when x is 5. So x times y gives us what for k? A positive 12. So we don't know y, which is great. And x is 5. Y equals? Sure, that's fine. We could say 2 2/5, or if, like you said, if you wanted to put it into a decimal, any of those would be acceptable. Did you get it? Okay. Thank you very much. Thank you very much.
And then on the first one, you have other staff on the bottom who are not in the grid.
Thank you. So you think you got all the staff? You don't say. Okay. All right, so real simple. Let's just do 291. Try numbers 3 through 8.